Hello, John Vincent back here with you. And in this session, we're going to be looking at NX cam customization. And inside of this little topic here, we're going to really focus on two different things. We're going to look at creating custom template files and what some of the various use cases are to set up various custom templates, as well as how to go about either editing your out of the box PAX file, or my suggested approach is to go ahead and create your own PAX file, which will organize your templates on its own tab under the File New menu. I find this to be the most user-friendly way, but again, however you want to do it in your organization is fine. And then the next topic will be utilizing the machining data library. So this will be using the combination of specifying part material, tool material, and cut methods, and then having those three criterias when they're filled out, be able to pull speeds and feed, depth of cut, step over, all that kind of information from the speed feed database. And we'll look at how to customize any and all of these values in this session. All right, so let's dive in and start looking at custom templates. So custom templates can be used for a number of different reasons, but I like to explain it as really what we're doing with templates is reducing the number of repetitive actions or tasks that a programmer has to go through on a daily basis. So some sample use cases of when you would want to use templates would be to go through and create standard setups that you use oftentimes in your production environment. So probably one of the most common scenarios is just based on the machine tool you're using. If you're using NC simulation inside of NX, you could have a template for each machine tool that you have built. So you're going to have the machine tool, the kinematic model loaded into your environment, which of course is going to post to the appropriate post processor and configuration files for looking at tool libraries and so on and so forth for that particular machine. But there's a number of different ways, of different things that we could also do. Maybe we have a machine tool that we have resident tooling in the machine, and we want to load up the first, 5 pockets, 10 pockets, 20 pockets with resident tooling that are always going to be in the machine, and then the remainder of the pockets in the tool magazine are then reserved for job-specific tooling that's going to come in and out of the machine with regards to what part we're manufacturing. That's one additional approach. Likewise to tooling, we could have operations in our templates. So maybe we would have our basic strategy for what we do to go ahead and rough our parts, semi-finish, finish our parts. Have those standard, very typical operations already created for us inside of our templates. So in that case, we would just be applying our geometries and any constraints for that specific job before we can go ahead and generate. So there's a lot of different things, and even more so. Maybe you wanted to have a setup for your ferrous materials and a setup for non-ferrous materials based on tooling, things like that. Or part specific, maybe a part family. You have, a part family XYZ, same process, same tooling, all that kind of stuff over and over. It's just the geometry selections are changing. So let's go ahead and dive in here and take a look at this sample part. So here, this sample template. In this template that we're looking at, and that's what's open right now, is a template file, and we can see a few things right away. We have a machine model loaded, so that's automatically telling me that, we have a machine tool loaded in the operation navigator on our machine tool view. But in addition to that, we see that we have some fixturing created here for us right away. In this case, we can see that we are looking at a machine, and it's got a quick change table. This happens to be a Dynafix table, but that whole palette can come in and out of the machine. And in this scenario, in our setup, we have a vice on here. So we can have a number of different setups available in our templates. We could have a single vice setup like we're seeing here. We could have a dual vice setup for doing multiple ops. We could have a chuck, grid plate, maybe a little tombstone or other custom fixture that we used oftentimes. Again, goes back to your application, what really makes sense. You can go ahead and do those things based on your needs. So, once you go through and customize your files, we're going to want to be able to manage our templates or be able to use those templates in one way. So what I like to recommend is here in the File New dialog, I like to create my own tab for a given company's manufacturing templates and model templates, drafting templates. So here we're looking at manufacturing, and we can go through and customize our own PAX file to include our specific company specific templates, so they're all listed in one location. Again, just going to be reducing number of tasks that operators have to do. So in this case, we'll take a look at this specific case of what does it take to modify these PAX files to make our templates visible inside of our File New dialog. So in this case, you can see I'm looking at our swoosh manufacturing template, but likewise we have the out-of-the-box tabs available here, and yours are going to change based upon your licensing and your configuration. So don't expect to see exactly the same thing that I have here. And of course, we can filter our templates by the relationship, which either means we're going to be referencing a part, so master model concept, or we're going to have a standalone blank file. And then the other filter is just units. Are they English or metric, or do we want to view all of these results? That's certainly okay too. So, what's really managing that? So here inside of our installation, so this is 1980. So inside of NX 1980 in the mock directory, we'll dive into the templates folder. Then inside of the templates folder, what we're really seeing here is a number of PAX files, and there's also going to be some JPEGs in here, some part files, things like that. But the out-of-the-box manufacturing information is all contained in the UGS _ manufacturing _ templates.pax. If we go ahead and edit this file, I use Notepad++ here, but any text editor is just fine. You'll see we have a series of some XML code. So if you don't know XML, that's okay. It's very easy to kind of copy and paste, and we're going to take a look at and correlate some of the various fields here to what you see in NX, so you're able to modify these. So first off, we see we have a palette command, and if we scroll all the way to the end of this library, we have our \palette. That's ending that command. So all of the entries inside of here, we see a series of different palette entries are contained inside of this one main palette. So a palette entry is all the information for one template. And inside of palette entry, we have really two types of information. We have our presentation information, and then we have the actual information. So that's going to be the information that we see here on the File New dialog. Or in addition to that, we have all the information pointing to where the actual template file is, images that maybe we want to show in the preview window, so on and so forth here. So the out-of-the-box PAX file, we see under the File New tab, it's called Manufacturing, and that's what's visible on the Manufacturing tab. Same thing, when we look at the first template available, this presentation name is Prismatic Milling and Hole Making. And again, we see that in our File New tab when we're looking at the part files. So now if we just keep looking at this file for a little bit, we'll see that there's other information. We're looking at some JPEG files. We're specifying some data here under the object data, specifying that, yes, we are working with a CAM template, maybe some file name, locations. Essentially, we're specifying a file location of where our part file is located that we're using for a template. And we're specifying a configuration file, and what units we're using. And then, yeah, are we using master model concept? Or no, we are not using master model concept. So that's the main content of what's included in each and every pallet entry. So once you have all this data, again, we're looking at the UGS manufacturing template. That's the out-of-the-box information here. So if we want to go ahead and change this or customize and make our own tab, it's really pretty easy to do this. Inside of that templates folder, we can just copy and paste, make a copy of the out-of-the-box option, and that's what I've done here with my swoosh manufacturing templates. And now if I edit that file, we can see that the format's going to look really the same here, only a few things that we've changed or modified. My file new tab name is now swoosh manufacturing. So again, that's going to correlate to what's visible on the file new menu on the tab. So there we see our swoosh manufacturing. Now if I just filter by all types here, we'll see I have one template, this Micron HEM 500U is what I'm calling it. And if we look at some of the information here, we have description information. It says high performance milling. It's also telling me my units, the name of the file. I have a swoosh logo in the preview window. So you could certainly put any images there, maybe regarding what type of setup you're doing or what the machine tool is, anything like that. Again, whatever makes the most sense for you. So going through and just copying and making this own standalone PAX file. As soon as you restart NX after making these modifications and saving, NX reads all the PAX files inside of this template folder. And as soon as you make the changes and have an additional file here, you'll have the new tab present in your NX session as soon as you restart the software. And so with that, you'll be able to go ahead, organize your templates, and have a little bit more standardization for your company. All right, so that's going to bring us up to the machining data library portion. So inside of the machining data library, we can manage a few things here, as well as set some different or create some different entries in some libraries. So what we're really going to be looking at here is part material. That's the image that we're looking at right now. And out of the box, there's half a dozen or so types of part materials available to us. But we can modify these. Obviously, there's way more than half a dozen materials. So we can enter in and create any type of material that we would like to have or that we produce in our organization. We can customize that into the software. And likewise, we can do the same thing with our tool material types. So this is not just limited to, saying high-speed steel or carbide or ceramic, so on and so forth there. We can include and start adding every type of coating we use. Anything that's going to require or you want to enable to make a different decision on, speeds and feeds. If there's going to be a difference in your speed, feed, depth of cut, step over, it makes sense to have the corresponding material in your libraries for, first we looked at part material, now we're looking at tool material, and then lastly will be cut method. So cut method, again, out of the box, simply 3 methods available to us. Rough milling, semi-finish milling, and finish milling. Again, this is filtered just for milling types. There's also drilling and turning methods, EDM. So here we have 3 milling types, but in reality, there's more cut methods that we utilize on a day-to-day basis. Easily you could have 3 methods specifically for roughing. Whether we're doing more of a conventional roughing strategy, slotting, things like that, versus a high-speed machining roughing method where we're going to be utilizing our adaptive cut patterns inside of NX. High spindle speeds, high feed rates, large depth of cuts, very small step overs, or our high feed milling where we're doing very low depth cuts but high width of cuts, typically used in hardened materials. So a number of different strategies, and we want to embed all that information in our libraries here. And lastly, we have the ability, once we do create all of our tool materials, cut methods, and part materials in the library, we have the ability to start populating our speeds and feeds and all the information associated with them. Now that data can come from any combination of data directly from our tool vendors, or it can be from institutional knowledge that's been acquired over the years, producing different parts, and we can start building our company-specific database. So this is really a great method for documenting standards. Essentially, that's what you're doing, is you're documenting all the known use cases for producing parts, and instead of having them in a binder somewhere, or in a programmer's head, or manufacturing engineer's head, you now have them embedded in your software, and you don't have the option to really lose them. So once you have this data populated, we need to assign the data, speeds and feeds, step overs, depth of cut, to our operations. So at a high level, two ways to do this. We have the manual method, where inside of each and every operation you can go into your speeds and feed dialog, click on the lightning bolt icon for setting machine data, and all the values will be applied, assuming you have a valid return when you search for that combination of part material, tool material, and cut method. If you don't have a valid combination, you'll get an error popped up that says, yep, no results were found, and essentially nothing is changing in your operation. So then that can mean a couple things. One, you can just make the settings manually, but it would also make sense to go ahead and notify whoever is the owner of the speeds and feeds information that, hey, we have a combination, we have a little gap in our database here, and let's figure out how we need to populate that. So I recommend that manual as you're building your database. However, once you have your database built, you can go to the automatic method, which can be specified in customer defaults to automatically specify your machining data in each operation. And the way this works, once that option is toggled on, as soon as you create an operation, NX is going to search for, based upon your part material, tool material, and cut method, what are the results? What are my step overs, depth of cut, speeds, feeds, all that stuff, and populated that in my operation. So the reason I suggest you wait until you have this operation, until you have your database largely populated, is every time you create an operation, you're going to get an error message if you don't have valid results. So just a little bit of an annoyance. So let's take a look at this. We're going to walk through here and create a custom value for all of these criterias for our part material, tool material, and cut method. And then we're going to apply them to this one operation just to show the concepts of how this really works in practice. So we can edit all this information, all these libraries. There's individual libraries or databases for each for each material or each entry, part material, tool material, cut method. And we can edit those through the ASCII files if you want it, just text files. But it's much easier to use the edit machining data library functionality here. We can edit everything through the graphic interface. So here on part material, we're just going ahead and saying that we're going to edit or insert a new material type. So we see on the top of this dialog, we see the library reference. That's being created for us automatically. It's just kind of a sequential number that's going to be generated. Then the fields below, the code, name, description, and hardness, are all information just for the programmer to see. NX is not going to be using any of this information while it's calculating speeds, feeds, any of that kind of stuff. Just for end user information. So yeah, we can simply go through, add in all the materials that we do. Same thing for tool materials. If we use many different types of either uncoated carbide and Tylon coated, zirconium coated, PCD tools, MCD tools, CBN, there's a huge list of different types of coatings available now. Not to mention getting into different grades of, if you're still using high-speed steel or cobalt, or ceramics for nickel alloys, things like that. You can enter all that information in, as well as cut methods. Again, I create easily 3 different cut methods just for roughing strategies. Looking at high performance milling, or kind of more conventional strategy with slotting, heavy depth, heavy width cuts. My high speed machining for using adaptive milling operations, and then a high feed milling type operation for using high feed mills. So many different strategies there. And of course, we can always edit any of this information once it's created. When you have your cut method, tool material, part material all specified, you can select them on the machining data tab, and you'll get any returns for speeds and feeds that have already been specified. And in this case, I don't have any because I created all of these materials and methods myself. So I need to go ahead and start inserting some data here. So when I select insert, I can specify speeds and feed information based on tool diameter. So in this case, I'm going to go ahead and enter, I'm entering data based on a 16 millimeter end mill. And I can enter in settings like depth of cut, step over. These are optional fields, so I can toggle them on or off. If they're toggled off, when I go in and apply this data, the operations just aren't going to be, the values in the operation aren't going to be overwritten. Whatever's in the operation is going to remain. So I can go ahead and continue just filling out all of this data, and NX will, when it's using this data, it's going to go ahead and reference and find whichever diameter tool is closest, or whichever entry is closest to the diameter tool that I'm using in my current operation. But as we all know, I can spell out information for a 16th inch end mill, or get it from a vendor, and same thing for the same series end mill, but in a 1-inch tool. We're not going to be using the same surface feet per minute or feet per tooth. There's just too much variability in between the size of the tools there. So that's okay. We can enter in this information as granular as we want. So we could enter it in for every diameter tool we use, or go through and say, okay, let me specify it for an 1/8 inch, 1/4 inch, 1/2 inch, 3/4, 1 inch, and NX will find whichever is closest that we're using in the tool diameter in our current operation, and use that data and calculate it based on that particular tool. So now we're going through and just specifying our part material, our tool material, and our cut method that we're going to be utilizing. Tool material, that'll come last year. We're going to create a new tool. And once we assign that, we are going to be using our new tool material type, we'll look at our operation here at some different information that's already exists. In this case, we'll create our end mill, and we're going to go assign the material now. And so once we do that, we'll okay this dialog and see some results. And finally, go and choose our swoosh tool material that we just created. So if we look at our operation now, we'll note that in the main page here, we see a step over value of 4.8 millimeters and a depth of cut of 1.23 millimeters. It's a very small depth of cut, still pretty small step over as well. More of a high feed milling approach here, you could say. But let's go over to our feeds and speeds tab now, and we can retrieve our results and set our machining data from the library. So we'll set our machining data. The actual speed and feed information has all been updated and calculated for this particular tool diameter that we're now using. And if we go back to the main page, we'll see that our step over and depth of cut have changed. So now we're using a smaller step over but a larger depth of cut. Kind of a traditional, more traditional cavity mill type parameters here. And we generate the toolpath, and we see, of course, the toolpath reflects the changes we've made in the operation. So yeah, speeds and feed library, great way to start standardizing operations and processes inside of your organizations. Thank you for your time, and we'll see you in the next session.